So last class we sort of looked at what is a neural network, or particularly what is a neuron, and how one can use that to classify data points that are separated by a hyperplane, right? So, and then we also saw how to combine them so that we can get a classifier that is more complicated than a simple linear classifier. Okay, so we just looked at, this is a big picture of what neural network is. And the second thing that we started looking at was, if you want to come up with an algorithm that will return a neural network weights which optimizes some loss function, then you have to have an algorithm, right? So basically a gradient descent sort of algorithm. So that means the algorithm, what it does is at each time it will give an updated neural network weights, right? So eventually, if you want to implement it, you should basically give certain guarantees, right, for the algorithm. If the algorithm will never settle, right, so it will keep on oscillating, then you will never know when to stop. And moreover, even if let's say the neural network weights sort of seem to converge to a point, then you should also talk about what is the performance and so on, right? So towards that, we started looking at the notion of convergence. So that's what we did in the last class towards the end, right? So what is the definition of a convergence? So when do you say that a sequence A n converges to A? Epsilon room definition, right? So you take a point A and then take an epsilon room around it, then the sequence beyond certain stage will enter that room and will stay there forever, right? If you if you reduce the size of the room epsilon, then still you can ensure that the sequence will enter that room, but perhaps at a later stage, right? So in other words, for every epsilon greater than 0, there exists a stage which is n epsilon, such that for every n greater than n epsilon, a n minus a, this is the epsilon room, right? So this is the definition of convergence. Is that clear? Any questions or intuition clear about this? Okay, so maybe we'll just look at one simple proof of convergence. Suppose, let's say you have two sequences. Let's say, okay, so problem. If let's say an converges to A and Bn converges to B, implies An plus Bn converges to A plus B. So how do you prove this? It's very intuitive, but how do you prove this? So I know that A n converges to A. So what does that mean? There is an epsilon room around A, so that the sequence A n will enter that room, right? So there exists so let's fix an epsilon. So give any epsilon, right? Any epsilon greater than 0. Okay, you fix this. Now for this epsilon, I can find a epsilon, the stage beyond which this will enter this room, right? So A n will enter this room. So there exists, let me call n epsilon by 2 of 1. So instead of taking an epsilon room, I'll take epsilon by 2 room. Okay, we'll see why that is the case. So such that for every n greater than or equal to n epsilon by 2 1, what will happen? A n minus A will be within epsilon by 2, not epsilon, right? So this is the first thing, right? So what is the second thing that you can expect? So similarly, for Bn, there is a stage, let me call this as n epsilon by 2, such that you take any n, that is a sequence beyond this stage, that is greater than or equal to n epsilon by 2 of 2, Bn minus B will be less than epsilon by 2, right? Beyond that, it will enter that room. Now, what is it that I have to prove? An plus Bn, which is a new sequence, let's say Cn enters an epsilon room around A plus B for sufficiently large n, right? That's what we need to prove. Okay, so need to prove that An plus Bn, this is Cn, minus A minus B, this is A plus B is your C, is less than epsilon for any n greater than or equal to some n epsilon. Okay, this is what we need to prove, and this should be true for any epsilon, right? So by the way, this whole statement that I have written here is true for any epsilon greater than 0, right? So now let's see how do you prove this particular thing here, right? So how do you prove this quantity? Now, instead of proving that this is less than epsilon, an plus b1, bn minus a minus b less than epsilon, I'll prove something larger than that less than epsilon. That's good enough, right? So let's consider this difference. an plus bn minus a minus b, I'll write it as an minus a plus bn minus b. Now, what do you think is the next step? Can you see direction here, how to go about proving this? Can somebody tell me? Triangular inequality, right? So what is that? An minus a plus bn minus b, right? But this is less than or equal to what? Epsilon by 2. I'll write it here. For all n greater than or equal to n epsilon by 2 of 1, right? Similarly, this will be epsilon by 2 for all n greater than or equal to n epsilon by 2, 2, right? Well, both will happen provided n is sufficiently large. It should be larger than the maximum of these two, right? If n is, let's say n epsilon by 2 of one is 100, the other one is 150, then you take capital N epsilon to be 150, then it will be always true, right? So this is greater than less than epsilon for every n greater than or equal to max of n epsilon by 2 of 1 comma n epsilon by 2 of 2, right? Is this clear? So that's QED, right? So you're done. Okay. So was there a question? Yes, Saurav.
Sir, how can we guarantee that both an minus a modulus will be epsilon by 2 and bn minus b modulus will be epsilon by 2? I mean, both the same quantity, how can we define? It should be one epsilon 1 and one will be epsilon 2.
No, so you give me an epsilon, I can guarantee that, right?
So, but both becoming same quantity in this case.
So you give me any error, epsilon, an will enter an epsilon room, right? That is guaranteed. So bn will also enter epsilon room around b. That is guaranteed by convergence of an to a and bn to b, right? So that will guarantee that you can always, so you should be able to enter. So supposing, let's say you travel from here to Bangalore, what does that mean? You converge to Bangalore, right? What does that mean? That means you should enter a 50-kilometer radius around Bangalore, right? And stay there forever. Otherwise, there's no guarantee that you will reach Bangalore, right?
Yes,
and stay there forever, right? So, well, you can shrink that 50, you can make it 30 and so on. So it doesn't matter. Is that clear?
Yes, sir.
Okay. Okay, so is this proof clear? Well, all the proofs will be along these lines. So you should think geometrically and convert the geometry into Greek and Latin, right? So this is in fact a very, very rigorous proof. Even if you go to any math class anywhere in the world, this is how the proofs are presented. Okay. Okay, so let's move on. So the other thing that we started looking at in the last class was what? Interval, right? What is an interval? Very easy, right? So we looked at various intervals like this: a comma b, closed on one side, open on the other side, both closed. These are the possible intervals that you can have, right? The difference is basically you will just not include one of the points, that's all. So then we looked at what is known as an open set. What is an open set? Can somebody tell me? When do you say that a set is open? You take a point, you take a point in the set, then you should be able to accommodate a small interval around it, right? If we can do that for every point in the set, we say that it's an open set. So for example, let's say 2 comma 3 union 100 comma 101. Okay, this is an open set, right? Well, this is not an interval. Why? It's union of intervals, right? Union of intervals can never be interval. Okay, so how do you mathematically define this open interval? You say that You take any point X in the set, there exists an epsilon room around it such that the entire epsilon room belongs to that set, right? That's how we defined an open set. Okay, so at least intuitively you got to know what is an open set, right? Clear? Okay. So these are some of the jargons you might need, but in practice, for example, if you want to implement a neural network or you want to achieve some data analysis task, then you may not need to know what is an open set very rigorously.